Hi there! Today we're going to speak about the representative sample definition. There are some methods to form a representative sample of n elements. Like in our previous example, we can just randomly pick up n elements from the statistical population. Go back to our example with the average height. Now let's use a less creative example of the population. Imagine that each point is an element in the population, and we want to form a representative sample. Suppose we have a result of the last population census. Then we can just mix up all the names and select n subjects to our study randomly. Chosen points are colored in red. This kind of sample is called a simple random sample and is really often used both in fundamental and applied studies. Another way to form a sample is called a stratified sample. This method is useful when elements in the statistical population can be grouped in a natural way. For instance, in our case, all men live in different cities. All the elements can be grouped by a very simple rule, a city's name. Each group of observations is called a stratum. After we group the observations, we can apply a simple random sample method to each group and select n elements randomly. The last approach to form a representative sample is called a cluster sample. This approach is often used in social science and economic studies and represents a combination of a simple random method and a stratified sample method. The first step remains the same. We group our sample to stratum, then select some strata randomly and use all the elements from the chosen strata to our sample. It is fair to say that the method to form a sample might differ across fields, but the main idea remains the same. The sample should be representative. This is the first and the most important condition if we want to make reasonable inferences from our sample data. And now you can check yourself. A sample is representative if it is big enough, at least 100 individuals. You can pause this video and try to guess the answer. The right answer depends on how the sample was formed. The next question. Suppose we asked 100 students of the St. Petersburg State University majoring in biology, aged 18 to 22, to take a biology test and record their results. To which general population can we generalize our conclusions? Biologists, men and women aged 18 to 22, St. Petersburg State University students majoring in biology. And of course, the right answer is the third one. Next question. After a lecture on statistics, a psychology student decided to find out whether psychology students are good on the subject. He prepared a test and asked 30 of his friends studying psychology to take part in his study. The student claims that he took a random sample. Is it true? Of course, he didn't take a random sample because not every psychology student could participate with equal probability. Only the student's friends were invited. So I think this was the obvious answer. Now let's look at the summary. The statistical population. What can we say about it? All the objects a researcher wants to generalize the results on. Statistical characteristics of GP are called parameters. Generally, there is no access to all the elements in the statistical population. To study different characteristics of population, a researcher forms a sample. And talking about a sample is a set of elements of statistical population formed by a researcher. A sample has to be representative to reflect properties of the statistical population. There is a list of techniques to form a representative sample. Statistical characteristics of sample are called statistics.